In this video, we will be evaluating limits and interpreting what they mean graphically. Limits are fundamental to calculus, so let's get some practice. I encourage you to pause the video and try this example out before we take it up together. In this first example here, we are asked, when x approaches 0, what is f of x approaching? So algebraically, what we're going to do to start this question is just try out direct substitution. So simply plug 0 into our function. When we do this, we simply get -2. So nothing too interesting here. The function simply approaches -2, which is actually its y value at x equals to 0. In our next example, we once again try direct substitution out, so plug 1 into the equation. You'll notice that something interesting happens. We get the form 0 over 0. Now, this is what we call an indeterminate form. It has no definable value. So to figure out what's going on here, we can try to simplify the expression, in this case by factoring. Because what appears to be happening is there's a term in both the numerator and the denominator that equals 0 when we sub in +1. So factoring the top and factoring that bottom difference of squares, we see that this x minus 1 term can cancel in the numerator and in the denominator. That was where our trouble was happening. So now simplified, we have the limit as x approaches 1 of x minus 2 over x plus 1. And at this point, we can do direct substitution. So now plugging in x equals to 1, we'll get -1 over 2, or -1/2. So what's happening here on the graph is we actually have a hole when x is equal to 1. In our next examples, we see something else fishy happening as well. When we try direct substitution again, we have a non-zero number divided by 0. So this is undefined. In fact, you'll notice that we will actually get two different answers depending on whether we're approaching -1 from the left or from the right. So let's take a look. So we know that if we divide any number by a very, very small number, it's going to explode to be very, very large. So what we're looking to see is this going to go to positive or negative infinity? Well, let's think about this. If we approach -1 from the left, so we're going to be slightly more negative than -1. So on the numerator, that would result in a negative value. And on the denominator, something a little bit more negative than -1 will also result in a negative value on the denominator. So a negative divided by a negative will get us positive. So this is going to explode to positive infinity. So now if we approach from the right, so numbers slightly bigger than -1, the numerator will still be negative. And the denominator this time, so numbers to the right of -1, this denominator will be positive. And so this side, it's going to approach negative infinity. So what's going on here graphically is we have a vertical asymptote at x equals to -1. In our next example, we have x approaching infinity, so very large positive values. Looking at our graph, we're looking at what's happening to the function as it goes to the far right side of the graph. What we can do to help see what's going on is we can divide by the highest power in the denominator, and this is going to help us see these 1 over x to the n terms, which tend to 0 as x approaches positive or negative infinity. So that's going to help us out in seeing what will cancel as x gets very large. So if we take a look at these terms here, we'll notice that 3 over x, as x goes to infinity, this will approach 0. 2 over x squared, similarly, as x goes to infinity, that's going to approach 0. And 1 over x squared, again, as x approaches infinity, that will go to 0. So we'll notice a lot of these terms will cancel out as we evaluate this limit. This will result in a final answer of 1. So right now we have a horizontal asymptote at y equals to 1. And for this particular equation, we actually get the same result when we evaluate the limit as x goes to negative infinity. So as x gets very, very large, or very, very large negative, this function is actually going to be approaching the line y is equal to 1. So there we have it. Taking a look at some of these limits really helped us understand the behavior of the function.